Cutting your electricity bill by 80% sounds less like optimization, and more like a complete shift in how energy is being used. For most people, the expectation is simple: use less, pay less. Turn off lights, switch to efficient appliances, maybe install solar panels. The idea of saving a bit each month feels realistic, manageable. But then claims like this appear 70%, 80%, sometimes even more. And that's where curiosity kicks in. Because reducing a bill by that much isn't just about efficiency. It suggests that something more structural is happening. Something beyond just using less electricity. So people start exploring. They look into alternative devices, energy-saving systems, and different configurations that promise to drastically cut consumption. At first, it often seems logical. Many homes waste energy in ways that go unnoticed: standby devices, inefficient wiring, heat loss, poor load distribution. Fixing those issues can make a difference. But then comes the disconnect. Even after optimizing usage, upgrading appliances, and being mindful of consumption, the numbers rarely come close to that 80% mark. There's an effort-to-result gap that starts to feel disproportionate. And that's where frustration builds. Because if the claim is real, then something is being missed. But if it's not, then what exactly are these systems doing that makes the results look so significant? Most explanations begin at the surface level: reducing waste, stabilizing voltage, improving efficiency. All valid concepts. All grounded in real electrical principles. But none of them, on their own, typically justify such a dramatic reduction. So the question shifts. Instead of asking, can this reduce my bill by 80%? It becomes, what mechanisms could create the appearance of that level of reduction? This is where things get more nuanced. Energy bills are not just about total consumption. They're influenced by timing, peak demand, rate structures, and how energy is distributed across a system. In some cases, shifting when and how energy is used can lower costs without drastically reducing total usage. For example, using stored energy during peak hours instead of drawing from the grid can reduce the billed amount. Improving power factor in certain setups can also impact efficiency and billing, especially in larger systems. There are also cases where part of the energy is coming from an external or previously stored source, batteries, capacitors, or even supplemental generation like solar. From the outside, it can look like consumption dropped significantly. But in reality, it may have been redistributed. And that distinction is easy to miss. Because most people look at the final bill, not the underlying structure that produced it. That's where perception and reality start to diverge. The real issue isn't whether it's possible to reduce an electricity bill. It is. And sometimes significantly. The real issue isn't even whether new systems can improve efficiency. Many do. The real issue isn't the percentage itself. It's understanding what is actually changing inside the system. Is less energy being used? Or is energy being used differently? Is the system reducing waste? Or is it shifting when and how energy is drawn? Is there an additional source involved? Or is the measurement incomplete? These questions don't invalidate the possibility of savings, they clarify it. Because once you start looking at the structure behind the numbers, the conversation becomes more grounded and more useful. Instead of chasing a specific percentage, it becomes more productive to understand where inefficiencies exist, how energy flows through your setup, and what variables actually impact your bill. That's the difference between reacting to a claim and being able to evaluate it. And once that shift happens, something changes. You're no longer trying to confirm whether a promise is true or false. You're building a framework that allows you to analyze any system clearly, logically, and without relying on surface-level impressions. If you want to go deeper into that framework, there's a structured breakdown in the description that walks through how to evaluate these systems step by step. And if you're interested in understanding how energy efficiency, billing structures, and system design actually interact, you can subscribe for more grounded, technical explorations like this.